This module examines break-even analysis. A common graphing method is to plot alternative quantities used in the formulas, essentially baking different quantities of pies. Our fixed costs of 925 stay the same regardless of the quantity level, so the solid black line is plotted across the graph. Total revenue, or TR in the prior formulas, increases as the set price is multiplied by different quantity levels. Those results are shown on the graph as the green line. Variable costs, which are a set amount per pie, in this case $1.45, are multiplied by different quantity levels and plotted on the graph as the orange line. Finally, total costs are a function of fixed costs, here including the profit target, plus the product of variable costs times different quantity levels, and then plotted on the graph as the red line. The red and green line crosses at 304, or the break-even point that will also make for us our required profit target of 400. Now let's change a few items in the prior example. Now we want to solve for variable costs, or small v. Assume you're planning another pie sale, but this time featuring a different pot pie that you will sell for $8 each. You expect to sell 250 pies at that price. Your fixed costs of 525 will remain the same, as will the profit target of 400. So the total fixed cost still equals 925. How much can you spend on variable costs? Just to be clear, you could use the formulas to solve for fixed costs if you didn't know that amount, but knew all the other amounts including variable costs. In this example, we know fixed costs, but not variable costs, or small v. Plugging these values into our formulas, we get the following. Quantity of 250 equals the 925 of fixed costs, which includes our profit target, divided by the result of the price of $8 minus our unknown variable cost. Rearranging the formula allows us to get closer to solving for variable cost. Using algebra, we multiply both sides of the equation by the right side denominator 8 minus small v. It cancels out on the right side of the equation, but leaves the left side with 250 multiplied by 8 minus small v. Then we move the quantity 250 to the right side of the equation by dividing both sides of the equation by 250. The 250s cancel out on the left side, yielding the equation of 8 minus small v is equal to 3.70, the result of dividing 925 by 250. Now we solve for small v, or variable costs, which is equal to that 3.70 divided by the $8 price, resulting in the calculated amount of $4.30 of variable costs that we can incur per pie. Given that we now know the variable cost, that solution allows us to derive additional information, including total revenue, total costs, and proof that our profit target is reached. Total revenue is equal to the price of $8 times the quantity of 250, which produces $2,000 in total revenue. Total costs are equal to fixed costs, excluding the profit target, of $525, plus the product of the $4.30 in variable costs times the quantity of 250. That generates total costs of $1,600. Profit, or Y, is then the total revenue of $2,000 minus total costs of $1,600. Our profit target of $400 is confirmed. If we knew everything about the price, we could derive a price which would cover all costs and profit. Price is equal to the product of our fixed costs of 925 divided by our quantity of 250, which results in 3.70. We then take that 3.70 and add the variable costs of 4.30. The result is that a price of $8 is necessary to cover all costs and our required profit. Price is simply the average cost of production. We can solve for quantity if we know the other factors. Quantity is equal to the 925 in fixed costs, that here includes profit, divided by the result of an $8 price minus the $4.30 of variable costs, or $3.70. When you divide the 925 by $3.70, you get 250, which is the quantity. This confirms the amount stated in problem B. In summary, there's very valuable information that can be gained by looking at the volume, cost, and pricing relationship. These formulas give the impression of preciseness. However, it's not all based upon estimating the service demand and agreeing on a price per unit. If you estimate service demand or sales too high, it may lead to funding more labor and materials than you needed. This will result in wasted resources that could have been better deployed. But if you estimate service demand too low, you may not have enough labor and materials to cover the demand as it occurs. Now, if you set the price per unit too high, it may drive away needy clients who can't and will not pay that price. But if you set the price per unit too low, it may not cover all of your costs. All of these decisions require careful attention to the cost, volume, and price relationship.